So welcome to all. So let us continue with the remaining concept. So the next thing is product of sums simplification. Now let us see how exactly we can do this product of sum simplification using that map reducing method. The product of sum form is a method of simplifying the boolean expression of logic gates. In POS form or product of sum form, all the variables are ORed. That means you have to go for OR operation. So that is written as sums to form some terms. Okay, so ultimately you have to get the OR form. Ultimate, that is the ultimate meaning. The all these sum terms are ANDed or multiplied together to get the product of sums from form. Okay, so this form is exactly opposite to SOP or sum of product form, isn't it? SOP is nothing but sum of product form. So in the previous video I already explained how exactly this POS and SOP works, but now let us see using this method how can you combine K map method as well, or map reducing concept as well. Okay, reduction rules for POS using K map. So there are a couple of rules that we use to reduce a POS using K map. First we will cover the rules step by step, then we will solve the problem. Okay, so ultimately how exactly we can do, so we will see in terms of image itself. So you can directly concentrate on image A. So here see, you have, it is a 4 variable K map, isn't it? So when you have 4 variable K map, how exactly you can work on it, we will see here. So there are 4 literals for WX as well as YZ. Okay, now in the same fashion you have to assign the binary bits for WX. So if WX are 0 0, and if it is 0 1, then if it is 1 1, and then if it is 1 0, so based on that, as it is a OR operation, or the literals should be OR, that is the reason why you are using a plus symbol in between WX and YZ. Okay, now when WX are 0 0, that is nothing but W plus X. When they are 0 1, it is W plus X dash. Now both the binary bits are 1 means you have to go for complement of both the literals, that is nothing but W dash plus X dash. So when it is 1 0, again it is W dash plus just X, because X value remains 0 itself. Okay, now for YZ, what you are going to do, again the possibilities are 0 0 0 1 1 1 and 1 0. So based on that, again you have to invert the bits. Now you can see in some of the places we have 1, so that ultimately means that the equation or the function they have given, so with the same function, they have gone for this particular 1 and respective position or respective squares are put 1. So this is just example to understand how exactly you can make this K map or map reducing concept. So I already in the previous video I already said how to put ones in a particular space, isn't it, in a particular square. So based on the function given or boolean functions given, based on that, by using or by seeing the actual function in concept, you can put the one in a particular square, and once you get the one, the adjacent cells can be combined, or if you want complete 4 ones in the adjacent rows or columns or in the squares, you can put a particular box to combine those bits. Okay, so that once we combine, we will get the simplified boolean expression or function. Okay, here also we are doing the same thing. So now you can see here, so the 0th position is put 1, first position is put 0, and the third position again it is 0, you are not putting 1. In the second position again you have 1. So like this you have 1 0 1 0 and consecutive respective bit values in a particular cells. Now if you concentrate on image B, what we are doing here, so instead of combining 1, here we are combining 0. Why? So it is complete ulta concept, isn't it? In the previous example, whatever the things we have seen there, we were combining 1. because you were and operation, you were performing and operation on literals, but in this case you are performing or operation on literals, isn't it? So that is the reason why you are trying to combine zeros instead of going for ones. Okay, now the adjacent or consecutive zeros should be combined. That is the reason why you are particularly putting that boxes to the zero places. Okay, in the same fashion, how exactly we can work on this, we will see in the next slide. So the first pair is w plus x dash plus y plus z into w dash plus x dash plus y plus z. This is the first pair. Now what is the first pair? So based on this image, what is the first pair? So it is nothing but w plus x dash plus y plus z, and into why you are going for into, because ultimately the both the values should be ANDed, isn't it? After ORing the literals, at the end you have to go for and operation. So that is the reason why after getting a particular space value or position value, that is after that you are going to AND the particular operation. Now that is the first pair. So in the second pair, what you are going to do? In the second pair you have w plus x plus y dash plus z dash. From where you got this w plus x plus y dash plus z dash? Again you have to come and see the image. So it is nothing but w plus x dash plus w dash and x dash you have. So in the same fashion you have here, when you combine zeros you get the w plus x dash plus y dash plus z dash. That is nothing but when you have 1 1 you will be having, when you have 1 1 you will be just a moment. Yeah, when you have 1 1 you are going to put dash or invert operation, isn't it? It is a ulta operation, isn't it? So you have to recall the concept of SOP and POS, how exactly you are interchanging the not thing, isn't it, or complement thing. So based on that you are going to get this particular pair values. Okay, the pairs are in product of sums, POS form. So in this particular thing we have the concepts or the form is nothing but POS form or product of sum form. It is not a sum of product, it is a product of sum form. Now we will remove the variable that changed in the first and second pair. Okay, so looking at the first pair, w changed to w dash, so we can remove it. So where you are saying that w is changed to w dash, so in the first pair see w plus x dash plus y plus z into w dash plus x dash plus y plus z. So w have changed, or the w literal has changed to w dash. So that is the reason why they are removing it. Looking at the second pair which has changed, so here in this case x has changed, isn't it? So that is the reason why the x will be removed. So after removing it, how exactly you can do it, or how exactly what will be the pair value then? So you will get the pair value as x dash plus y plus z, and for the second pair you have to remove x dash or x value. So that is the reason why the ultimate pair value will be w plus y dash plus z dash. Okay, so note, pair reduction rule removes one variable. So when you have pair of values, it will be it will reduce or remove one variable. But in the same case, if you are going for multiple values or multiple positions, how exactly we can do it? So it is a quad reduction rule. So you have one more concept called quad reduction. Quad means 4, or a combination of 4 places. Okay, so the example remains the same, whatever the example we have taken in the previous thing, but here see number of zeros they have increased. Some positions are marked as zeros, again based on the function or boolean function given in the question. So I just have taken the actual concept instead of going for theories. I just wanted to show you with the particular example, so this will be easy for you to understand the concept, as well as whenever you go for the textbook or whenever you go to the particular example, you will recall these things. So the same thing they have written in their sentences. They did not change anything, but here I am explaining the example. There they have given in the sentences, that's it. Okay, now you can see in this particular example, in the image, right hand side image, you have one a series of zeros, isn't it? So quad zeros, complete quad adjacent cells are combined, and they are grouped together. All the zeros are grouped together. Now you have to remember why you are grouping here, because here it is a OR operation. At the end you are going for ANDing of the things, isn't it? That is the reason why here zeros are given more importance than 1. But in the previous video we were combining ones instead of going for zeros. Again, it is because of SOP and POS. So based on the form, you have to consider the or you have to consider the method to pair the bits or bit values. Okay, so this is how the concept works. Now here see, you have combined 4 zeros in the both the places with the different adjacent cells. Okay, now how exactly we can pair it, we will see. The first quad, so first quad, what that first quad will do, the first quad will be obviously w plus x plus y plus z. Now why it is w plus x plus y plus z? So when you have this one particular value, that first position, that is nothing but w plus x plus y plus z. How you got that? Because the first position bit value, that first square, will represent all zeros. So if it is all zeros, means obviously your value will be w plus x plus y plus z. Okay, now what is the second thing? Into w plus x dash plus y plus z. Again come here and check how exactly you got that. W plus x dash plus y plus z, the second row first square, second row. In the same case, how to represent third row and first that column or first square? Again it is w dash plus x dash plus y plus z. You can see here w dash plus x dash plus y plus z. In the same fashion you are representing all the cell values, but you have to remember using OR operation, and when you go for the second square, it should be ANDed. That position value should be ANDed. That is the reason why in the brackets they write, and after that they put one dot. Okay, this is how you are representing first quad and second quad. Now once you done with this, so we will see what to remove and how to remove. See, now we will remove the variable that changed in the first and second quad. So what are the variables which have changed in first and second quad? Look at the first quad, w dash and x dash. Okay, now in the first quad, w dash and x dash, they have changed to w and x, so we will remove it. In the second quad, what are the concepts they have changed? So it is x dash and z changed to x and z dash, complete ulta. So you have to search like this. You have to search in a particular function, you have to, or in a particular quad, or pair, or octet also possible. Octet means grouping 8-bit positions, adjacent 8 bits, complete 8 bits will be 0, or complete 8 bit will be 1. So based on the functions given in the, or based on the boolean functions they have given in the question, based on that you can build this particular map, and you can search for the adjacent values and you can group them. Based on that group you can get the first square, quad, or second quad, or first pair, second pair, or first octet, second octet, or like that. Again it depends how many bits you have. Based on that you will group it. Okay, now based on this changing concept, you are actually removing it, so that you can reduce the total number of functions, or the entire function will be reduced to smaller size. Now the first quad, after reduction, how first quad will look like? So after reduction, after grouping up and after reduction, you will get at the end y plus z itself. Now how y plus z you obtained? So when you combine the two octets, or sorry, two quad, or in the first quad, they are actually divided in two parts, isn't it? So w plus x plus y plus z into w plus x dash plus y plus z. Now how they have reduced that particular thing? They have reduced to w plus y plus z. Why? Because in this square x has changed to x dash, that's why they removed it. And in the second part, what they have done, w dash the second part of first quad, I'm talking about second part or right hand side part of first quad I'm talking now. It is w dash plus x dash plus y plus z into w dash plus x plus y plus z. Now what has changed here? Here x has changed, isn't it? So that is the reason why that x has removed there. So it is ultimately what you get. You get y dash plus y w dash plus y plus z. Now in that particular thing, what has changed? Now y has changed to y dash. That is the reason. Sorry, w has changed to w dash. So ultimately the what is the concept has remained there. Y plus z has remained there. In the second quad, what happens? Again in the second quad also the concept remains same. The reduction will plays the major role here also. How to reduce? Whatever the literal values have changed or whatever the variables have changed, whatever the input of that label has changed, that will be removed, and ultimately you are going to reduce the entire equation into a smaller part. Now ultimately you have reduced the entire thing to y plus z as well as w plus y dash. Ultimate value will be like that. Okay, note quad reduction rule removes two variables, so ultimately it is going to remove two variables. So these are the some of the examples I have taken for mainly for this product of sum simplification. So whenever you have the concept of product of sum simplification, you have to follow these steps. Okay, so try to take some examples. So definitely when this assignment concept comes into picture, definitely I will include all these things, so you will get that time you will be able to solve it, and you will get the rough idea of this. As well as you can go through the textbook or internet, you will get so many examples on this particular concept. Take those examples, try to solve it. If you get any doubt or if you get any error, please get back to me. I will solve and I will give. Okay, so let me wind up the video here. These are some of the concepts I just wanted to discuss. Rest of the concept we will see in the next video. Okay, so yeah, thanks for watching.